You haven't seen it?
I've only seen the first one.
Okay, on number 20, it's a given that those lines are parallel to each other. So if these lines are parallel, what do I know?
They're congruent.
Okay, whenever you have parallel lines, there are certain angles that are going to be congruent. You guys remember our parallel line chapter?
Yeah.
What, like, for example, what angle would be the same?
Alternate interior.
Alternate interior. So in this picture, it would be like this angle and
That one.
this one.
Yeah.
Okay, and if these two lines are parallel, kind of the same thing, this one and this one. So this angle would be the same as,
That one.
alright, you guys see it? Okay, do we have enough info to say these two triangles are, and if the line is shared, that's going to be congruent in both triangles. You guys remember what the reason for that is? What we called it? Reflexive property? If it's congruent to itself, equal to itself. Do we have enough to say the triangles are congruent?
Yes.
What?
Angle side, angle. Yeah.
Okay. And so you were also supposed to say the triangles are congruent, like triangle ABC or whatever is congruent. So notice they're kind of like flipped around. Like this angle matches that angle.
Makes sense.
Okay, I also added a gift on
A gift. I saw that. That ain't no gift.
number 23.
Wow. Yes, let's go, dude.
That's right, Paxton.
No, Paxton, go back to sleep.
Paxton, you're welcome to stay awake today.
We should make Paxton do this problem.
Oh, it's proofs too. Yeah.
Oh man.
Wait, did you say? Wait, did you say 23?
23 is added on. It's pretty short.
Is it this
I
side?
like those ones.
I think it was 3. What?
You said side.
Yeah. No.
But
Okay, look. What do we got here?
angle side.
Alright, so anyway, we're going to do 23. We haven't done one of these circle ones yet, and we've got like 2 today.
Oh.
That was
Let's see.
So, the given is just circle P. I just wondered if they call this PAC because you guys know why they named it Pac-Man. That just crossed my mind.
Did you say the given circle P?
Yeah, the given is circle P, it just tells you right there. So, remember we have statements and reasons for those statements.
Oh.
And the given is just circle P, there's not really, the circle symbol is a circle with a dot in it, so it doesn't look like it's full. Okay, well, let's figure out what we're trying to get to, and then we can maybe reason backwards to figure out where we need to start. Oh, the power flash messed up my stuff. Okay, so what they told us to prove was that, we don't know this yet, they told us to prove these two angles have to be the same. Why must these two angles be the same?
Is there a base?
Because P is the middle. P is the middle. And they both go to P.
It's the base.
What do you mean it's the base?
Like, it's like on an isosceles chart.
Okay, how do we know this is isosceles though?
You don't.
P. Because P is in the middle.
You just wish it was.
The circle.
No, we do know.
It has two equal sides.
In a circle, what are these called in a circle?
Legs.
Radius.
Radius. Plural is
Radii.
radii. What do we know about radii in the same circle?
Oh, they're
They
equal.
equal.
They're congruent.
Oh.
So we do know it's isosceles, so we do know that those are basic. Okay, so that's basically the proof. We just need to say it. Okay, so what did you guys just say again?
radii are equal.
No. That's the reason.
Isosceles.
No, that's, how do I know it's isosceles?
Because
Two equal sides.
What sides are congruent?
The PA.
CP and AP.
Okay, PC and PA are congruent. So that's the statement. Because
Radii are congruent.
that's how you spell radii, by the way.
It's goofy.
3 eyes.
Just two.
Bro.
Can you count? No, because there's like 3 eyes.
One of them's in the
That's
Next
pretty
word.
different.
That's an N.
IN.
Dude, I say you want.
So it's RADIIN.
Yeah.
I
I,
thought
that's it. Same circle.
it looked like I.
Actually, it's RADIII. Okay.
Plus 7.
Can I write too many eyes?
I guess if I did
There's
write
a
3
line.
eyes, would you like count it off?
Wait.
Okay, so now I know that these two are congruent, so what can I say now?
The
CA or angle. P.
Well, let's say, what do I know about this triangle? Let's say that first.
isosceles.
So, triangle PAC is an isosceles triangle.
Yeah.
That was only 3.
Yeah. I thought this would be a good one to throw in there. We should probably say this. And how did I know? Why did I know that?
Because 2 equal sides.
But yeah, you're getting close.
2 equal sides.
Yeah, which is basically, that's what you're saying is it's the definition of an isosceles triangle.
Definition.
Definition of isosceles.
Is there gonna be proof on the test?
Could be. Alright, so we got an isosceles triangle, now what? Do I know these two angles have to be congruent?
Yes.
Yes, but why do I know that?
It's a base.
Okay, base angles in an isosceles triangle are congruent, or it actually has a name. It's called the isosceles triangle theorem. So you can either say the rule, the base angles in an isosceles triangle are congruent, or you can say the name of the rule, if you remember it, isosceles triangle theorem. So I'm going to say angle A is congruent to angle C, or angle PAC is congruent to angle C. What we're trying to prove. Angle PAC is congruent to angle PCA. Isosceles triangle theorem.
This is PAC, like pack and pack man.
Even
Where
here, I said
have
that.
you been?
Oh, you said that?
You're about 4 minutes behind. I just had that sudden realization 4 minutes ago.
You want an iPad or something? I had it in 2 seconds.
I think somebody in the other geometry class realized it, but I didn't really think about what they were saying.
So you just.
Let me guess, was it Skylar?
No, I think it's Eli probably.
Probably was.
Eli Goofy.
You always said that before.
Okay, ready? Ready to roll? 33. These are kind of weird. I actually skipped this book lesson. It was about right triangles and hypotenuse leg. You guys remember hypotenuse leg is the only one that only works on right triangles? But what they're saying is, this is matching, by the way, A, B, C, D, E. Match each right triangle. So these are all about two right triangles being congruent or not. So on 33 it says LA. What do you guys think LA might stand for?
Los Angeles.
We're talking about right triangles. So what might the L stand for?
Leg.
Leg,
Uh,
angle. So what that means is, it's kind of like hypotenuse leg, right? So what that means is, if one of the legs is congruent, remember these two things are legs. If you have one pair of congruent legs, and one pair besides the 90-degree angles, one pair of congruent angles, how do we know these two triangles are congruent?
Angle, side angle.
Angle, side angle, which is option, this is matching,
Oh, it's matching.
B. Okay, but what if I had put the angle in the other corner? Is that angle, side angle?
The angle, side.
Angle, angle, side. So 33 is the only one that has two answers. Angle, angle, side is C.
You have to put all that applies through.
Yeah. I just said 33 is the only one with two answers. Okay, anyways, that's 33. 35, what's that say? Was it LL?
Hypotenuse leg.
Oh, well, okay. So, hypotenuse leg, that's the hypotenuse, and one of the legs looks like that. Okay, well, which one would that be? Side angle, which is which option? No, I mean A, B, C, D, or E. It's E, it's not one of the normal ones. Okay, on 36, I'm not going to make you do a proof for that. It's kind of the same thing as 32, though. What do you guys think LL means? Leg. So if those legs were both congruent, you just tell me, how do we know those two triangles are congruent? If both pairs of legs are congruent, just say how do we know the two triangles are congruent?
Wait, what do the legs mean?
The legs are the sides around the 90-degree angle, not the hypotenuse.
Is it saying like, how do you know which leg it's talking about?
It says leg, so that means both pairs of legs are congruent.
So then, what would you,
So how do we know the triangles are congruent?
because,
To try and draw this. Okay.
The hypotenuse is like the long stretch, right? You know what I'm
The
saying?
long one, yeah. Crust, it's opposite the 90-degree angle. Not my favorite letter. Alright, I redrew 27,
37.
37.
I was
Statement. Reason. What we are trying to prove, but we do not yet know, is that VS and VU are congruent. So that. We can't use that right now. I'm just saying that's what we're trying to get to. Okay, so, oh, I missed something.
Mr. Jordan.
The given says, I forgot those. The given says the figure. So what do I know just by looking at the picture?
S, D, and T, U are congruent.
No, we don't know that just from looking at the picture.
Oh.
What did they kind of give us in the picture? No,
Oh, reflect.
no, that's not given.
Right.
oh, the middle
Right
one.
triangles.
They're right, yeah,
Oh.
they're right triangles. Or the right angles, you could say. I'll say angle VST and VUS, or VUT are right angles. here's the plan. We're gonna, like pretty much everything we've done in this chapter, we're gonna try to show that these two triangles are actually congruent. So what do I know besides the right angles?
Yeah, VT was congruent.
Okay, VT is congruent to itself.
Yeah.
What was the reason for that?
Right triangle.
Yeah. I mentioned it earlier. Reflexive property. Stuff being equal to itself, basically. Okay, so we have a side. Is that enough?
No.
Now, what else do I know? Somebody said it earlier before
ST.
Angle STV.
No.
No, angle,
ST.
VST and VUT are both congruent, those angles.
Okay, that's
Angle-
true.
Angle ST.
We could say that, but we're not gonna happen to need it. It's not gonna help us actually.
Angle STU is congruent.
Nah, that's only one angle.
ST and TU.
Okay, just like 23, right? These two are the same.
Okay.
Oh gosh,
Uh-oh.
I don't know what I did. What have you done, you monster? All right. So ST is congruent to TU because. Because why?
Because
Radii. Excuse me.
Rad would do it.
Why is it a lot?
All right. Do we have enough to say the triangles are congruent?
Yes. HL.
Right. Since it's a right triangle, we don't really have to say that right angles are congruent because, yeah, we have hypotenuse, right? Leg. I didn't draw that very well. It's kind of bugging me. Oh well, I can't fix it. Okay. So triangle, I'll say VST, VUT are congruent. Because all right, is that what we're trying to prove?
Yeah.
No. What we're trying to prove actually, I forgot, is that these two are congruent. Why do I know that those two are congruent?
It's like, wasn't that one thing you said that one
Yeah.
Oh, like that really long abbreviation.
The C, like PCC.
There you go, good job. So once you know that triangles are congruent, you know their matching parts are congruent, right? So corresponding parts of congruent triangles are congruent, or CP, CT. So what we're trying to prove, VS is congruent to VU. Corresponding parts of congruent triangles are congruent.
Now.
Okay, 39, the last section. This was Monday's assignment. You guys remember Monday?
Yes.
It was all about. You guys remember what this was called?
Midpoint or mid segment.
Mid segments. And what's true about mid segments?
Say we can
They're in the
find
middle.
it.
They're
They
in
connect the
midpoint.
midpoints. What else do we know?
They're parallel to the base.
Parallel, which means like we know stuff about angles on parallel lines. What else do we know? There's one more thing.
Yeah, it's like half of
Yeah, it's half of the
Oh, yeah.
side that it's parallel to.
Half of the base.
Yeah, mid segments. So, and we had some formulas that we used with this one a little bit.
Oh
You
yeah.
guys remember the distance formula?
Yeah.
Parentheses x minus x, and then square plus parentheses y minus y squared.
And then, okay, we did do the slope formula,
Y
for,
minus y.
but I don't think they put that on this review. But they did put the midpoint on here. So how do we, you guys remember
Y
the,
over y minus y over x minus a.
no, that's just, this is the slope formula,
X
which
plus
they're not
X.
gonna ask us today. The midpoint, you average the x's to get the x coordinate, so x plus x over 2, and then you average the y's to get the y
So yeah,
coordinate.
yeah.
We do need both of those today. Alright, so, I should have drawn that probably. If I can, no? That was just way too much work. Looks like that,
How's hair was in motion cloud?
question mark.
I thought you said Coach Club there.
Okay, so the first one is find angle UVW is 39. UVW is right there. The only angle they really give us in the picture is 44. If this is 44 degrees angle R, what else must be 44 degrees?
G.
No.
Because it's not.
Okay. Remember we know lines are parallel, right?
Yeah.
So,
W.
Oh, so it's VB.
well,
W.
VWT.
Yeah, VWT.
It's like these two right here, right?
Oh.
So you see how they look identical? That's kind of a, yeah. These triangles are actually all congruent to
Would
each
that
other.
also mean that SUV is also? Because of like.
Yes, SUV is also going to be one because it's, yeah, these two are parallel. Okay, but if this is 44, what else must be 44?
V, or the UVW.
UVW, because you guys know why?
Interior angle, or interior corresponding angle.
Yeah, it's basically one of these things, alternate interior.
Alternate interior.
So yeah, it is, anyway, the only angle they gave us is going to be the answer, 44 degrees. All right. 41 says UV, which means find the length from
UV
U,
lights.
U to V. What do we know about the length of UV?
It's half the distance of RT.
Right. UV is going to be half as long as RT. So if we can figure out how long RT is, how can we figure out how long RT is?
By the y minus y, x minus
UV is 4.
No, it's not going to be that nice. Okay, why is this not 8? Because from -2 to 6 is 8.
Because the y-axis.
Oh.
Because it's not a straight line, it's going down some too. So it's like dropping. So yeah, we need to use the distance formula. So x minus x is -2 minus 6 plus y minus y. Oh boy. -8 squared is 64. 1 squared is 1. Squared is 65. Does that simplify? No. No, that's like 5 times 13. It doesn't simplify. So if this is square root of 65,
Square root of 35.
no, that's not how it works. works. Okay, we basically need to divide this by 2, right? Is that gonna simplify?
No.
No. Square root of 65 is a really weird decimal, so we're not gonna change it. So it's just square root of 65 divided by 2. (43). 42 says find the coordinates of W. What do we know about W? How could we find the coordinates for W? Right, it's the midpoint of R and T, so you can use the midpoint formula with R and T. Okay, but 43 says find the x coordinate of S. So if you look up in the picture, it says S is at x4. We need to figure out what that x value is. This one's kind of confusing, so it's kind of lucky this is an odd, but it does not give us the coordinates for U right here, but we do know something about the point at U. It's the midpoint, but what about the, what would the x coordinate for U be? It is 0. Were you just guessing?
Yeah.
Okay, well, I didn't draw it in my picture, but in the book, they drew the x and y axis like this, right? So if the point U is on the y axis, then its x coordinate must be 0.
That
Okay, so if U is the midpoint, that means its x coordinate should be halfway between these two. Or another way to think of it, how much are we increasing by to go from -2 to 0?
2.
It's going up 2.
Yeah.
Just kidding.
From -2 to 0, from -2 to 0, it's going up by 2.
Yeah.
So from here to here, since it's like the same thing, it should be, the x coordinate should be going up by 2 as well. Or you could say like -2 plus x divided by 2 should equal 0. Like the midpoint formula. If you average those two together, it should equal 0. Or you just think, what's between, or -2 goes up by 2, goes up by 2, what's this going to be? 2. 0 is halfway between -2 and 2. So 2 is the coordinate.